Hi there. Welcome to the 10-Minute Analyst, where we turn complex institutional research into intelligence you can actually use.
Every week, we dissect the latest reports from banks, summarizing the charts, the data, and the bottom line into a concise podcast and visual deck.
It's open source intelligence for the modern professional. Now let's dive in.
By 2028, the world's biggest tech companies are going to take basically 90% of their operating cash flow, which is about $1 trillion, and essentially set it on fire to build the physical foundation of artificial intelligence.
Yeah, it's an unbelievable amount of capital.
Right. And the wildest part of this whole financial model is that by 2029, they plan to just abruptly stop the spending spree.
We're looking at a projected capital expenditure cliff that, defies almost every historical rule of technology deployment.
Yeah, usually when things scale to billions of users, the infrastructure costs just scale right up with it.
Exactly. But here we're seeing this massive, localized detonation of capital that's expected to peak and then just cool off right when the technology actually reaches true ubiquity.
And that contradiction is exactly why we're doing a deep dive into this today. Welcome to the show, by the way. We've got our hands on a fresh, highly detailed financial research report from Barclays Capital, Inc.
Dated March 11, 2026.
Right, titled U.S. Internet and Semiconductors, Framework for Modeling AI Demand and Supply. And just to be clear for you listening, this is not like some opinion piece or a philosophical debate about the nature of intelligence.
Oh, no, not at all. This is forensic financial modeling. Barclays is actively tracking the physical supply chain, the global energy grid, and the internal budgets of the hyperscalers. The Amazons, Googles, and Microsofts of the world.
Yeah, they're literally mapping out human technological progress over the next 4 years through spreadsheets.
Because the underlying premise of this framework is that money moves because the actual technology forces it to move. That $1 trillion figure isn't just an arbitrary budget.
It's a mathematical necessity, right? Driven by the physics of computation.
Exactly, and by the rapidly compressing timeline of AI breakthroughs.
So our mission for this deep dive is to unpack why this financial peak is happening, how the power grid can even handle the strain, and what this condensed timeline means for you. Because by the end of this decade, this trillion-dollar furnace is fundamentally going to change your career.
Oh, absolutely. It's going to change the very nature of the digital coworkers you manage.
Okay, let's unpack this, because to understand the money, we really have to first understand the sheer panic that's driving these tech giants right now.
The panic is entirely about a compressing timeline. The Barclays report highlights that the transition between technological epochs, it's shrinking from years down to months.
Like, think back to 2025. The industry standard was assisted workflows. You'd write a prompt, the model generated some text or code, and you reviewed it. You were still driving the car.
Right. You were the driver, and the AI was just a really capable engine. But now, moving through 2026, we are fully entering the era of agentic AI.
And that shift is huge. It means the AI is taking high-level intent from the user, breaking it down into distinct goals, calling on external software tools,
and, crucially, monitoring its own progress to correct mistakes along the way.
Yeah. It's the difference between asking a calculator for a square root and asking a junior analyst to, pull a market report, format it, and email it to the whole team.
And the enterprise market is responding to that shift with extreme aggression. Leading AI labs are seeing their annual recurring revenue, their ARR, jump by 20 to 35% in just a matter of weeks during Q1 of 2026.
Which is insane growth. I mean, Anthropic soared from $1 billion in early 2025 to $19 billion. OpenAI rocketed from $6 billion to $25 billion.
Those revenue figures definitely validate the massive investments made so far, but honestly, they are just the preamble.
Just the warm-up.
Right. As fast as the adoption of agentic AI feels today, the Barclays framework points to 2027 and 2028 as the true point of no return.
Ah, the RSI window.
Exactly, the projected window for achieving RSI or recursive self-improvement.
Let's break down the mechanics of RSI for a second, because this right here is the catalyst for the entire trillion-dollar projection.
It is the whole ballgame.
Right. Because up until now, humans have been the bottleneck in AI development. Human researchers are the ones designing the model architectures, curating the data sets, tweaking the algorithms.
But RSI is the threshold where the AI models become sophisticated enough to take over their own research and development.
They literally learn to rewrite their own underlying code to run more efficiently.
And they start generating their own high-quality synthetic data to train the next iteration of themselves.
It's wild. It makes me think of an analogy. It's like having a factory that manufactures machines, but suddenly the machines start designing better versions of themselves while they're still on the assembly line.
What's fascinating here is the velocity this unlocks. Historically, we saw, about 1,000 days between the release of GPT-3 and GPT-4.
Yeah, almost 3 years of massive human orchestration, debugging, testing.
Right. But once a model enters a stable RSI loop, that release cadence just collapses. The system starts operating in a continuous automated cycle of self-evaluation and upgrading.
And if even one major AI lab achieves that exponential compounding, it triggers an unavoidable arms race.
Mathematically unavoidable. I mean, imagine you're the CEO of a hyperscaler. You see a competitor nearing a stable RSI loop.
You're terrified.
You're completely terrified. Because if they cross that threshold and you don't, their models will begin iterating so rapidly that your engineering team will never be able to catch up.
The gap in intelligence just widens by the hour.
Exactly. You are facing an existential threat to your entire business model. You either spend whatever it takes to build the compute capacity to hit RSI first, or you just accept permanent irrelevance.
So if every major tech company realizes they are facing corporate death if they lose this race, that desperation completely breaks normal corporate budgeting.
Oh, completely. It shatters it.
Let's look at the math of that panic. Because of this impending RSI milestone, the physical infrastructure required to train these models is about to break all previous financial constraints.
Barclays estimates that the capital expenditure for these hyperscalers will peak in 2028 at roughly $1 trillion.
$1 trillion. I mean, the magnitude of that number, we really need context here.
Well, Barclays notes this estimate is $300 billion higher than the current Bloomberg consensus.
Wow. So the broader financial markets are vastly underestimating the sheer volume of capital about to be deployed.
Vastly. We're talking about tech giants taking around 90% of their operating cash flow and diverting it into AI infrastructure.
90%. They are essentially turning their massive, globally diversified businesses into giant funnels just to buy chips and power.
And the power side of this equation is where the models hit the hard reality of physics.
Yeah, let's talk about the power grid. Because by 2029, Barclays calculates the industry will need roughly 23 gigawatts of entirely new compute capacity just to handle the training loads of these RSI loops.
23 gigawatts. To put that in perspective, that's the equivalent of spinning up 23 brand new nuclear power plants.
That's just mind-boggling. We're talking about millions of miles of copper wire, massive new substations, which, by the way, have years-long wait lists right now.
And data center cooling systems that rival municipal water grids. The bottleneck isn't just money anymore.
Right. It's the physical supply chain of the planet.
Exactly. And to put a finer point on it, the report breaks down the specific needs of the leading labs. OpenAI and Anthropic alone are projected to require 15.5 gigawatts of that total.
Which translates in hardware terms to an estimated 6.2 million next-generation chips, dedicated purely to training.
NVIDIA B200 equivalents, yeah.
But wait, looking at the data for those two specific labs, I have to point out a massive discrepancy in the Barclays framework.
The training compute gap.
Yeah. Wait, the report shows OpenAI's training compute forecast for 2029 is $120 billion. But Anthropic's forecast for the exact same year is only $35 billion.
Right.
OpenAI is projecting they'll need to spend more than 3 times what Anthropic plans to spend. If they are both racing toward the exact same RSI future, why is the gap so wide? Like, is OpenAI wildly overestimating to secure funding, or is Anthropic dangerously under-resourced?
It's a great question, and the report flags this specific anomaly.
Yeah.
They trace it back to their divergent strategic architectures.
Okay, how so?
So, Anthropic has maintained a laser focus on enterprise models. Highly reliable text-based tools built for deep corporate integration and complex reasoning.
Right. Very focused, very specific.
But OpenAI is pursuing a much broader multimodal strategy. They are trying to process real-time, high-definition video, native audio, control consumer hardware devices.
They're essentially trying to map the entire physical world into their models.
Exactly. And processing reality in all its messy, multimodal glory requires exponentially more data and compute than pure text reasoning.
Ah, that makes total sense. I mean, teaching a model to understand a complex legal document takes deep logic, sure.
Right.
But teaching it to understand a live video feed of a busy intersection
requires reasoning plus a massive amount of spatial, temporal, and visual data processing.
Right.
But ultimately, the report suggests these figures should theoretically converge as we approach true state-of-the-art frontier models.
Soda models.
Yes. For those unfamiliar, SOTA state-of-the-art refers to the absolute, most capable, highest-performing model in existence at any given moment.
The bleeding edge.
Training that definitive SOTA model, the one that actually triggers the RSI loop, is the ultimate constraint driving this entire ecosystem.
So whoever figures out the architecture for that breakthrough basically dictates the ceiling for what must be spent across the whole industry.
Bingo.
Okay, so the industry is throwing $1 trillion and 23 gigawatts of power at this in 2028 to train these godlike SOTA models.
Yes.
But if I follow the logic of standard technology scaling, if the AI keeps getting smarter and billions of people start using it, the spending should just keep climbing, right? More usage equals more servers.
You would think so.
Yet Barclays predicts the exact opposite. They forecast the capital expenditure will hit that $1 trillion peak in 2028 and then completely flatten out or even decline. How is it possible that demand explodes but infrastructure spending drops?
The answer lies in the fundamental mechanical difference between training a model and running inference on a model.
Right. They are two entirely distinct computational processes.
Completely distinct. Training is the act of building the intelligence. It involves feeding the model trillions of data points and constantly adjusting billions of parameter weights to minimize errors.
Using backpropagation, right, calculating gradients backward through the network.
Exactly. It is incredibly dense, heavy computation that demands the absolute newest, fastest, most cutting-edge silicons strung together in massive clusters.
Well, inference is just the execution phase.
Right. When you, the user, ask the AI a question, the model isn't learning or adjusting its internal weights. It's totally frozen.
It just takes your query and pushes it forward through the network, a forward pass, to infer the correct response based on the training it already has.
And inference is exponentially lighter on compute, because that forward pass doesn't require constant multi-directional mathematical adjustments. It doesn't need bleeding-edge infrastructure.
It runs perfectly fine on older, slightly slower hardware.
Precisely.
Here's where it gets really interesting. Barclays outlines what they call the Waterfall Framework.
The hand-me-down effect.
Yes. Every year, the hyperscalers buy the newest, most advanced chips to train their next frontier model. But instead of throwing away last year's training chips, they simply repurpose them to handle inference for the end users.
It makes total economic sense.
It's exactly like upgrading to the newest, most expensive water-cooled gaming PC for yourself to play the latest releases on max settings.
Sure.
But when you upgrade, you don't trash the old one. You hand your old gaming rig down to your little sibling to do their basic homework and web browsing.
Right, and the homework still gets done perfectly. The machine is still incredibly powerful for that specific task.
And you didn't have to buy 2 brand new computers. The old hardware cascades down to meet the lower tier demand.
If we connect this to the bigger picture, the math of this waterfall effect is stunning. The report calculates that by 2027, the installed base of old training chips trickling down will be more than enough to cover the new inference compute required by the entire global user base.
So the supply of repurposed chips organically outpaces the demand for inference. But wait, doesn't the shift to agentic AI kind of blow up that demand curve? The report specifically notes that a reasoning or agentic query requires 7 times more compute power than a basic single-shot query.
It does. It's a much heavier lift.
If an agent is constantly looping, checking its work, calling outside tools to say, build me a website that's 7x multiplier on billions of daily queries, feels like it should totally overwhelm the waterfall.
It's a massive multiplier, sure.
Right.
But the sheer volume of perfectly good hardware flooding the inference layer from the training clusters is so vast that it absorbs even that 7x surge.
Wow, really?
Yeah. Once those recursive self-improvement loops are running efficiently by 2028 or 2029, the frantic need to build entirely new, massive training clusters cools off.
Because the models become highly optimized at training themselves.
Right. The $1 trillion peak is just the brute force required to push the boulder up the mountain. Once it crests the peak and momentum takes over, the capital requirements normalize, and the waterfall handles the rest.
So all of this, the 23 gigawatts of power, the $1 trillion in corporate cash, the cascading waterfall of silicon, none of this is happening in a void.
No, it translates directly into reality.
It translates directly into how you, the listener, will interact with the digital world by the end of this decade. Let's look at the human scale of this infrastructure.
The projected user base baked into these financial models is honestly breathtaking.
Yeah, let's look at those numbers.
Based on the inference compute forecasts, So the budget specifically allocated for people executing forward passes on these models. Barclays calculates the global system will handle over 10 trillion AI queries per year by 2030.
10 trillion.
And the driving force isn't just new users coming online, it's the intensity of the usage.
Right. Back in 2025, the average user was executing about 3.6 queries a day. Mostly simple things like drafting an email or summarizing an article.
But by 2030, Barclays expects that to jump to around 7 daily queries per user.
And remember, these are complex agentic queries requiring multiple hidden steps.
Exactly. And when you take the total inference budget and divide it by those daily usage patterns, the math backs into an astonishing projection.
4.3 billion weekly active users in the AI industry by 2030.
To ground that 4.3 billion figure, consider that today there are roughly 5 billion total internet users globally, if you exclude China.
So the financial models are basically banking on AI becoming as ubiquitous as the internet itself within a 4-year window.
Yes. It won't be a separate application you open. It will just be the default invisible interface for every digital interaction.
So what does this all mean? It means a complete redefinition of the labor market and corporate structures.
It really is a paradigm shift in economics.
The report outlines this shift where the concept of human labor is directly competing with compute cost. Like currently, a corporation might pay a human worker $20,000 a month fully loaded.
Right. Factoring in salary, benefits, payroll taxes, office space, all of that.
But Barclays suggests that as we cross that 2028 peak and the waterfall of cheap inference chips floods the market, those same corporations will pay a lab like OpenAI or Anthropic maybe $1,000 to $2,000 a month for a drop-in digital employee.
This is the ultimate destination of that transition from assisted workflows to continuous autonomous operation.
You'll no longer view software as a tool that needs your constant input. You'll view it as a subordinate.
You'll assign a complex, multi-day project to a drop-in digital employee that sits below you on the organizational chart, and it will just execute that project independently.
And that $1 trillion capital expenditure in 2028, that is the necessary down payment to fund this exact societal diffusion?
It ensures the infrastructure exists so that, say, a single-person startup can effectively employ a staff of dozens of digital agents operating 24/7 at a fraction of the cost of a traditional workforce.
You aren't just going to be a user anymore. You're going to be a manager of a digital team. Let's briefly recap the scale of the journey Barclays has mapped out here. The entire tech sector is in a dead sprint toward 2027 and 2028, desperately trying to be the first to reach recursive self-improvement.
That threshold where models upgrade their own architectures.
Right, because losing that arms race means corporate extinction. The hyperscalers are going to burn through $1 trillion and 23 gigawatts of power grid capacity by 2028 to train the ultimate frontier models.
But thanks to the mechanics of the Waterfall Framework, where state-of-the-art training chips cascade down to run low-cost inference, that staggering infrastructure spend will hit a peak and stabilize.
And it's that stabilized, massive infrastructure that will allow 4.3 billion of us to affordably hire our own drop-in digital employees by 2030.
It's a remarkably cohesive and elegant financial model. However, this raises an important question.
Oh.
One that could fundamentally shatter this entire timeline.
Okay, what is it?
Buried deep in the caveats of the Barclays report is a really vital piece of context. Their entire data set specifically excludes sovereign AI and China.
Wait, really?
Yes. This trillion-dollar framework is based entirely on the budgets and behaviors of Western corporate hyperscalers and Western AI labs.
Oh, wow. That completely changes the context. This isn't a global ceiling. This is just a regional corporate estimate.
Exactly. The report assumes that Western corporations are going to max out their own financial limits, spending 90% of their operating cash flow to win this race. But what happens when nation-states decide to enter the compute arms race in full force?
Right. We are talking about geopolitical entities with bottomless GDP-level budgets.
State-owned power grids. Intense national security motivations.
If global governments decide that owning the best RSI model is the equivalent of owning the nuclear bomb in the 21st century, does the 2028 financial peak actually happen?
Or does geopolitical competition obliterate this corporate financial model entirely, driving the arms race well past $1 trillion and forcing the timeline far beyond 2028?
That is a staggering thought to leave off on. I mean, if publicly traded corporations are willing to spend $1 trillion just to protect their software margins, what is a superpower willing to spend to protect its global dominance?
It really makes you look at those massive humming data centers very differently.
It does. They aren't just the cloud anymore. They are the new geopolitical frontline.
Absolutely.
Well, thank you so much for joining us on this deep dive. As you head back into your day, take a look at the software you're using right now and start thinking about how you're going to manage your own drop-in digital employees in the very near future.
Because the trillion-dollar foundation for them is already being poured.
Catch you next time.